But did we discuss any of this? Did we discuss, for example, structured English? Did we give examples? Somebody to unmute and bring me to speed. Structured English only. Okay. Then I think when we were discussing the structured English, I think then I can assume that we were giving an example. For example, if you want to get the sum of any two numbers, I think I can guess what we were going through, and we said that you have some structured way of doing it. For example, you will say enter a first number. We have enter second number. Then we'll say add first number to second number to get sum, and then we say display sum. So if you look at that, it is structured English because we are not two-wordy, and as we are doing it, we are using some controlled language. Structured, the word structured here basically it means that we are basically using the language you're using is controlled. This one here, structured, we are using some controlled language. For example, enter or input, then add, then display. Then we are not two-wordy, we are not writing like a composition. Basically, it is few short lines. We are putting very few short lines, like what we have done it. So we are using very short lines. We can use get, we can say input. For example, we can replace this one with input instead of even enter. I think the best term should be input. So input first number, input second number, add first number to second number to get sum, then we say display sum. So basically from this, you can see that we can actually now be able to do what? We can be able to get the sum of any two numbers, because if you ask enter the first number, 9, enter second number, 2, add the 2, so 9 plus 2. So then we say the sum equals 11. So display 11. So it will display whatever was put in sum. Of course, you know, when you say enter first number and we have a variable here, the computer goes to the memory and reserves a location for first number and will enter inside there. When you say second number, again, it will go to the memory and it will reserve and you put 2. Then again, add number to sum. Sum becomes a variable. You go to the memory, reserve a location for sum, and then it will put 11. So then when you say display sum, it will be reading whatever is in that variable that is called sum. That is what it will be doing, and then you'll get the sum of any two numbers. And we can go this way and maybe ask ourselves how, for example, do you get the sum of any four numbers, and then you see what to do. But we can make this a bit complicated, and we ask ourselves, assume you get, we want to get the sum of any. We are putting any so that somebody will put any 10 numbers, the sum of any 10 numbers. Okay, can you put it on the screen? I want you to do it. The sum of any 10 numbers. Do it from your screen. Just type the message. Then you can type in Word. Then you paste Hapa so that we see the message in the message box here. We want to see those answers here. The sum of any 10 numbers. Okay, can you do it? Then you see it. Do it now. Very well, very well. I think I can see very good answers. You have noted that those who have entered, those who have done the attempt, of course, there are variation input X, initialize sum to 0, initialize if count is this, set sum to 0, blah, blah, all this. Of course, one of the things that you realize is that you cannot go this way, the way we have done here, enter first number, enter second number, enter third number, enter fourth number. It will be quite boring. So you need now to be cognizant of what we call the 3 basic building blocks. You must be cognizant of the 3 basic building blocks. That is one thing that we must be aware of. 1, sequence, 2, selection, and 3, iteration. We must be clear of this, so that we say sequence in where statements, line of statements, 3 basic building blocks. You might have called them control structures before. You can either control them, you can call them control structures, or the 3 basic building blocks, so that we say that when you go to sequence, then you are executing one statement after another, one statement after another. When you talk about selection, then here there are alternatives. There are alternatives, or there are options. Like we gave an example, if you talk about your sex, you can either be male or you can be female. Okay? When you go to grading your marks, you can get an A, you can get a B, you can get a C, you can get a D, or you can get an E, but you cannot get both A and B. Iteration, this is looping. And you are doing looping when some block of statement, where block of statements have to be executed more than once. So we need to be cognizant of this, so that now in this program, we can modify it. And for example, we can say that we can put initialize a sum to 0. Then we also say initialize count. We can put a count here, or counter to 0. Then from here we could we will modify it. We can add person. We can even give numbers to these lines now. Let's give numbers. That's number 1, number 2. Let's put one as number 3. Enter a number to count. You can add 1 to count. Once you do that, what do? We can now come here and maybe ask a question. Is count, maybe test if count is, we are going up to 10, is less than. We can just say if, or you can even remove the test, because already we are testing. If should be capital. If count is less than 10, then we say go to is capital, go to 3. So else, that if that is not the case, display sum. Display sum. Now, and we can go through that line of code. Of course, one of the other concept that we'll have introduced is the question of variables that we have actually introduced here. We have introduced variables, if you look at it. Now, when you start putting sum, count, number, then these are variables. Now, so we'll be able to talk about the qualities of a good algorithm. The qualities of a good algorithm, we'll look at it. But before we go there, let us come here. Initialize sum to 0. So you have, immediately you tell the computer, go to the memory, reserve allocation called sum, put 0. Initialize count to 0. So this is sum it is 0. Then you go initialize another one here, and this is 0. It is, sorry, count. So this is count, and you also put 0. Enter a number. So of course now it allows you to put a number, and this number, it is any number. So for example, if you put the first one, and let's reduce this one so that we don't take a lot of time. I'm reducing this one to 4 because this program should be generic. Enter a number. So I'll enter 3. So once I enter 3, sorry, here at this point, enter a number. So I enter 3. Add number to sum. So this is sum. So it will be plus 3. So it gets me 3. So that location will be replaced. So sum will no longer be 0, but the value in that box will be 3. Then you say add 1 to count. So add 1. So this one gets to 1. And then it tells you if count is less than 4. So what is count? What is the value of count? It is 1. We are at this point. The value of count is 1. 1 is less than 4. So what do we do? Go to 3. What is 3? It is this one. So we go to 3, enter a number. It tells me enter a number. Now I enter another one, 2. So I enter 2. So then it goes to this one. It tells me add number to this. So it adds 2 here. So the value becomes 5. So the value inside here will be now 5. So then it goes on, add 1 to count. So add 1. So it gets me 2. So the value there will be 2. Then if count is less than 4, so 2 is less than 4. So again, go to 3, enter a number. So we put here, so we now put a number here like 4. So then what happens? Add number to sum. So we come here and add 4. So we get 9. So the value becomes 9. Then add 1 to count. So we add 1. So it becomes 3. Then we say if number is less than 4, 3 is less than 4. So what do we do? Go back to enter a number. So I enter 6. Then add number to sum. So we'll add 6. So we were at 9 plus 6. So it gives me 15. So the value here of sum will be 15. Then it tells me add 1 to count. So add 1 to count. So it becomes 4. Then if count is less than 4, 4 is not less than 4. So it will not kick this one back, but rather it will go by sequence downwards. So it will display the value in sum, and the value inside the box called sum will be 15. So it will display. So this program, I'm able to do it. I can see it here that, for example, I'm looking at the one for Okemwa. Sum is 0, then count equals 0, then you are putting that. You are put while. The only problem with the while, it looks a bit advanced, but at least it can show that you're using structured English. So what we are simply saying is that in this program, then you can see that it's a bit neat. It is not clustering. It's not too much clumsy. So it is a good program if you look at it, and it is not very complicated. So using this, first of all, then we can now go and ask ourselves from what we have done here, then we can look at the qualities. Now we can look at the qualities of a good algorithm. The qualities of a good algorithm, the first quality is that it must be correct. It must be correct because we have already tested and it is doing what it is doing. So it must be correct. So it must be correct so that it's doing the right thing. 2, it must be understandable. And in understandable, number 1 is number 1. There could be many attributes of this algorithm. We are saying there could be, so there is correct, then there is understandable. There could be many more attributes, for example, but when you now talk about understandability, then you see there are several things that are causing this understandability. And one of the things that will make understandability to be easy, as we can see here, one is that ensuring that we have variables that are descriptive. Variables that are descriptive will make the program easy to understand. Like we can see here, we are putting variables. Here, there's a variable called sum. Descriptive meaning we can tell what it is doing. So sum, we know what it is doing. Count, we know what it is doing. So basically, we can tell what it is doing. But the other one, which this one we have not really demonstrated here, is that another thing is that if you look at what we are doing here, if we had a program that is broken into many, we can say we can use modular program. But another one is that it must be concise. It must be very clear on what you want to do. I'm just putting some of the the things that you need to see. And understandable, you can have, if you have variables that are descriptive, you can have modular program broken into. But what you can see here from this, we might not see the modular because you don't have a big program, but you can see that the program has variables that are descriptive. So we are able to tell what the program is doing. So that even here in the, if count is less than, for example, 10, we can just change, because this is counted, is counting the number of times you are looping, then we can reduce this one to 4 very clearly. Of course, this program, you can see that it is adaptive. You can call it adaptive. You can call this one scalable. It is scalable if you look at it. We have scaled it. The program we had before was for 10 items, but the same program can be adopted for 4 items because we did not want to take the whole day trying to really test it. But equally, if you look at it, you can see that even if you need to get the sum of 1,000 numbers, you only need to change this. So the program here is actually short. It is clear. It is, we can even say it is maintainable. The program must be maintainable. The algorithm must be maintainable. It is easy to maintain this algorithm, so to speak, because you can even do that. You can even test it very easy. You can see what it is doing, so you can actually be able to test this program. These are some of the attributes. You can read about more attributes of a variable, but from this you can see that we are doing that. And as we do this, we are aware of the 3 control structures. We have seen that. We have to be aware of the 3 control structures we have implemented. This one, we can see that simply by sequence with the program, you must have initialized sum to tell you returning that you must have a variable called sum. You must have a variable called count. You must enter number. So it is by sequence. So this one comes, this one next, this one any can come before the other. But enter number comes after this. You cannot add, very important here, this one, this line. Number 4 cannot come before 3. Number 4 cannot come before 1. So by sequence, so 1 comes before 3 and 4. So by sequence, you run 1, you run 3, you run 4. Then you have number 5. Number 5 cannot come before you have 2. So 2 comes, then 5 comes. Then you come to check here. You cannot come to check here about count if you have not already had 2 and 5. So by sequence, you are saying by sequence, something is happening. Then this line number, when you talk about if, the if here, the if is the one that this statement, if count is less than 10, this part here, it is the option, the selection. And then the go to, this part for go to, the one we had the go to here, we have cleared the go to that is helping us to go to 3. This is the loop, we are looping. So we are repeating this line 3, 4, 5, and 6. We are repeating several times. Because they are repeated several times, that is iteration. That is what you're talking about. So with this program, the improved program here, we can see that we have implemented the 3 basic building blocks. So we have actually implemented 3 basic building blocks when we look at that program. Very well. So I think we are done with that representing algorithms. And the next method of representing algorithm is the use of pseudocodes. So we talk about now the pseudocodes. So pseudocodes is close to pseudo, of course, pseudo not real, but code is, that means you have coding, but not very real coding. So basically, you're not using a real programming language. We'll go to that program that we have just had, and we now go to very close to programming code. So we can now go and do sum equals 0. So you see the other one, we were putting initialize sum to 0, but here we are putting a statement. So we can put now a statement that sum equals 0, count equals 0. Then we can go on, and now maybe we put now the do while count is less than 4. Then we can even ident, we can input number, and then we can come here and say sum equals number plus sum equals number plus sum, count equals count plus 1, and then we can go on, and now we loop. At this point, we can loop, and then we display sum. So we are having the program do while count is less than 4. So we can see here, this program as we are doing it, it is very close. It is very close to the real program code. It's very close to the real program code. In actual sense, it looks like we are actually now doing the real programming. So, but again, if you look at it, it is not real programming. So, but at least it's helping us to represent the algorithms using a way that is closer to the real programming. So that is what we are talking about, an example of pseudocode. Basically, what we are doing is that we are actually translating our we are actually translating our structured English and putting it into pseudocode. That is exactly what we are doing. We can test ourselves. So unless there's a question there, so that one is just changing. We are moving from what you can call structured English to pseudocode. And looking at the code that you have there, you can see it's very close. So unlike why we're saying initialize, you're putting statements, initialize sum to 0. Initialize, here we are short, very precise. We are very precise, and then we put as it is. So we use that kind of a thing really to represent that. Good. We have discussed the qualities of a good algorithm. Of course, one of the things that we saw in this program is that we did some walkthrough. We did some walkthrough, we call desk checking, to validate the program. You remember that when we wrote this program in structured English, there is something that you remember we did. We tried to walk through and to see how the program is running. We call this one, we are validating the program. Of course, what you're doing is testing the program. And specifically that type of testing, sometimes we can call it desk checking. Desk checking. Desk checking is where desk, not desk. Desk simple problem. We can think about a simple problem, and then we can use it really to work on it, and then we see how it will work. We will start with a very simple problem of getting the average. So you work on this, then you write this, the average of any 4 numbers. Code. All right, a pseudocode, we see it on the screen. Do that. Pseudocode. given, you need to initialize average. They need to be initialized, which basically you need to initialize to 1, because you cannot initialize average to 0, because average is a product. So I can see, for example, on Deo, have initialized average to 0. It cannot be average to 0, because once you average to 0, then that is a product. So you know it will mess things up. Majority have not initialized average. Majority have not, but those who have those who have initialized, they are put. Okay, so I think we can have many more examples. We can have many more examples of that. I will go to the last way of representing algorithms, and that is what we call the flowchart. We'll still use the same method of the same problem. I think this one for getting either the sum of two numbers or something like that. And we look at the flowchart. We are looking at the last method, that is the flowchart. And when we talk about the flowchart, then we look at the flowchart symbols first. We of course have the start and stop, that's the sign. This is the sign for the start and stop. We have the data flow that we put like that, representing how data is flowing. We will have a process, that is the process, and then we have the decision. But we have another one that is called the connector. This is a circle, not, this is, remember the input. So this is the input output, or sorry, the start, not the input, start, stop. Then this is data flow. This one is a process. And then this one is a decision. This one is a connector. But we have another one. Don't know whether it can be. Let me just draw that one. We have another one. This one. This one is input or output. We have input, output. We have input, output. So those are the symbols that we have. So we can use the example again that we are having, the example of just processing these data. So we can go to start here. So we have start, and then we flow. We will do this together. Let me join. I can even use this one. I hope I've shared the screen I shared. So we can go to now. From there we had some process. This is a process where you said sum equals 0, count equals 0. Sum equals 0, count equals 0. Then we continue. So we have sum equals 0, count equals 0. Then we can have from there we input a number. So we can now input that number as we can input the number at this point. Might not be very good, the diagram. Input number. So at this point you can input number. You can input number at this point. So then after inputting, this is now we can go down and we can ask the question. We can have not after inputting the number, then again we do the process. We do the process. This is a short one. So we do a process, and the process is again here, and the process here is we are saying that sum equals number plus sum. Sum equals number plus sum. At this point, and then we can now come to ask the question. This is where we can put this. Is can put count is less than 4, for example. So if count is less than 4, then we loop here. We loop up to that point. So this is the loop. We get up to that point. So we get there. Else, if not, we can use now the connector here. This is the connector. And the connector comes here. Else, if meaning if then you can now come here and display. You are just outputting. So this one is a display. Display is this symbol here. So you can come here and display sum. We have sum here, and after putting sum, then you can continue and stop. After doing that, you can stop. So so this is a simple process. So we start, we get the sum equals 0, count equals 0, input number, the sum equals number plus sum, count, then we continue sum. If count is less than 4, we continue, but if count is 4, then it continues to display sum here, then you stop. So this is a simple way. And the 3 start and stop, this to do the summation. Then we have the input there. Again, we have another process. So this is a process. This is a decision. They have the decision here. And this to show that the same. Then we have sum there, displays an output. Then you come here, you stop. So this one, we are now representing the same program using this. So these are the 3. We have the decision tree, decision tables. Those ones we can think about them later, or we can first of all look at other things. So those are the 3. Those are the 3 ways. We'll first of all think about the 3 ways of representing algorithms. So we are having the structure, we are having the pseudocode, we are having the flowchart. I don't know whether there's any question so far. I have no. Oh yeah, I have not incremented count. Yes. Yeah. We increment, yes. So we can simply come and do the increment of the count, and we say, yeah, count equals count plus 1. Yes, count equals count. Yes, very good. It's a process. So I hope that I've not forgotten something else. Very well. So, any question on that? Any question? Okay. I'll give you a task. First of all, now the far we have gone, I think we can we can now think of cat one. We can think of how we can do cat one with pseudocodes or algorithms, and we can do. There are many algorithms. We'll continue, but we can do cat one so that we catch up with the time. So, but meanwhile, I want you to try another problem. We make the problem a bit complicated, not the ones we were having. And I want you to think about your class. I want you to think about your class. Or I think we can think about, let's think about your class. And let us think that we want to get what? I'm trying to think about the problem. You want to get the tallest guy in that class, the tallest student in that class, and the shortest student in that class. So I want you to come up with a pseudocode. I want you to come up with a pseudocode, and once you write that pseudocode, it should be able to tell us who is the tallest person, and we'll go through it. Who is the tallest person? Who is the shortest person in the class? How many people are in groups? You can, if where you are seated, if where you are accessing the class from, you're in a group, raise up your hand. If you're in a group, just raise up your hand. Several people are in two groups. Okay, very good. Okay, so if you're in a group, then you can do as well, no problem. So we'll give you how many minutes? We give you, you can lower the hand now. So we can give you 10 minutes to do that. 10 minutes. 10 minutes. So now it is 8:27. So by 8:37, we come and see what you have displayed here. 10 minutes, please, starting now. Maina Muigai. I don't know whether Maina Muigai is alone or with the group. I need to test it if it is working. Now, I want to pick minus algorithm here, and I want to put it here. So that this is what I'm just picking one of the algorithms. Now, when you have an algorithm, you have to test if it is working, like the one we have there. So if you look at it, input height. So you have put height. For example, assume maybe it is in feet. You have put that is 5 feet. Then you say set tallest equals shortest. So you have a variable called tallest. You have a variable called shortest. So you have put tallest equals 5 and shortest equals 5. So set that to be that. For I equals 2 to n, what is this? I equals 2 to n. What is 2 to n now? This one, I am not understanding what is happening there. That one I'm lost. This line. Okay, but we can input height. So you put input height again. So you have another height. So this is, let's put a variable. Let us ignore, we don't know what is happening there. But we have this one called height. This is tallest. And this is shortest. Let us see whether it will work. Height. input height. So put now 6. There's a fellow of 6 feet. If height is greater than tallest, if height, this is height. If it is greater than tallest, so tallest is 5, it is greater, yes, then tallest equals height. So this one becomes 6. And if height is less than shortest, so it continues. If height is less than shortest, this is not less than shortest, then shortest equals height. So this one, it will not replace because this is not less than this. So tallest, okay. So here, it looks is working. Whatever the Madhaudani he has done here, it is working. In tallest, so this one, this so you're inputting twice. This one, this one is the one that is making it work. So if the only problem, assume there is only one student who comes. This one will not work if there is only one student who comes to class, because already you have put it here that the tallest is 5 and the shortest is 5. It has initialized. So this one, it is telling us there are 2 students, where one of the student is 5 and the other one is 5. So basically, if, and then you are telling it to input. Yeah, it will be showing you have 2 students here. Yeah, this one will be showing you have 2 students, because first of all, there is the first height you have put here. This is the first student. So this first student, tumemweka hapa, it comes, first of all, you have input height of the first student, but then you're inputting height again here. There are 2 inputs, this one and this one. So this is wrong, because you are putting the height twice. Input height. So you are put, okay, you are put here, you are put here. Are you going to put the same height or different one? Because this will prompt you like to put another height, a different one like this one. So this one, hapa, this one having these heights the same place, the same, that causes some little confusion. There's a confusion there. Let's go on the second one, but at least there's a good trial. What I'm simply saying is, were it not for this first line, the core of the algorithm, this one is working right. This one is working right. Hapa, it's working. So shida iko hapa. Hapo ndio shida iko. But this one is working. That one is working. The loop, inside the loop is working. We go to the second one, tallest name. We wachana na name. Sasa huyo anaweka name ya nini? We don't need tallest name. We are not putting the names. Read student name. Name for what? Forget about, just deal with one item. Height. This is the group of Odell. Just use one. Height. Wachana na name. We only, for now, we are only dealing with one variable only. Student height. If student do, so the initialization has a problem. Most of you, the initialization has a problem. Wengine hata hawakuandika kitu. I'm only seeing 2 students. Yani class iko na watu wangapi? 182. You cannot tell me that all of you are in these 2 groups. Three groups. There's a group. There is Maina Muigai, have sent. Then there is Odeo Nyamache has sent. And then there is Maina Muigai. Maina Muigai has done it twice. So it's only 2 who have done it. Maina Muigai and wengine ni kungedia tu hapa kwa class. Wanangoja mwalimu apeane answer. So Odeo, at least you have not initialized properly and you're putting the name. I think looking at the two programs, the only one that looks like closer to the answer is this, but the confusion is here. The confusion is here. So I think this one can be a class assignment. Go and work on this individually, and then a very simple problem. A very simple problem. First of all, you don't know how many students are coming to class. Let me explain this. It become a clinic. If you are running a clinic, you do not know how many people will come to a clinic that day. You are having for health or recruitment. Yes, kuna ile ilikuwa police recruitment. kwa jamaa mmoja alikuwa amesema ameenda 7 times na hajachukuliwa. Now you're going for police recruitment and you want to take the height of the recruits. You want to, because unapima kila mtu. Now you don't know how many people are coming. So you need an heading condition. But you need somewhere to be able to determine who is the shortest and who is the tallest. That is the challenge I'm simply giving. Go work on that. You write a pseudocode and then you draw a flowchart. Think about it. It's a challenge. You tukutane kwa cut. Tukutane kwa cut. We'll be discussing algorithm from the beginning, introduction to data structures and algorithms, how to do the algorithms, all these up to what pale tumefikia leo. So cut next week. Have a nice weekend. Tuonane next week. Tuchape your cut. We might do 2 classes. Somebody, yes, Tony. Tony, you have raised the hand. Tony, Keremi, I thought I'm seeing the hand raised. I'm listening to you. Aya. Kama ulikuwa unajaribu kama hivi vitu zinafanya, inua mkono IC and I'll have to give you an opportunity to ask the question. Online or physical? What? The cat cannot be online. Look at this guy. Are you asking the class or the cat? The cat will be the cat will be physical. Lazima ukuje na ujaze uweke karatasi hapo. So Tony, you better pray. How do you want us to do an online cat? So that you see, like now I'm giving you an assignment here at the group work. Hakuna group work. Group work fanya hii. I've given you group work. Do that problem I've given. Do that one. That's Gashau is sending the answers now when we are already done. These fellows. So we'll meet next week on Friday, then we do the sit-in cut. But we might start with a normal class in the morning, and then later on we meet for that. Very well. I think we'll stop at that. We meet next week. Prepare time. See the normal. I think it's 3 p.m. and in Olemoyo. I think that is what we said. I told you. Let me check that email. It was from Dan. It is score 204. Just a minute. It was sent to me. Just a minute.